Hello guys, my name is Sheikh Mohammad Fawaz. I'm studying in Sri Venkateshwara College of Engineering. Today we'll be discussing a topic in ETC, that is Automata Theory and Compiler Design. So the topic for the day is regular expressions. So we'll be studying in this presentation what are regular expressions, what are languages, and we'll consider a regular expression that as a problem. So, what is regular expression? Regular expressions are algebraic way of describing languages. They describe exactly the regular language. If E is a regular expression, then a language of E is known as a language it defines. We will discuss regular expressions and their languages recursively. So, like we discussed, regular expression definition is the languages or the languages of the expression. Basic first, if a is a symbol, then A is a regular expression, and L of A is A. That is nothing but double quotes A is a language containing one string. That string is of length 1. So we can see here this string which the language consists is 1, that is A. So basic will summation is a regular expression when L of E is all present languages are uh, used in the string. Phi is a regular expression when L of phi is null. Then the second definition is introduction. Uh, if E of 1 and E of 2 are regular expressions, then E of 1 plus E of 2 is a regular expression too. That is, then it similarly implies that language of regular expression 1 and 2 is equals to language of regular expression 1 union of language of regular expression 2. So by this we can say that these are the similarities and relations between the two languages as well as the regular expressions. If E of 1 and E of 2 are regular expressions, then E of 1 into E of 2 is a regular expression too. The language of E of 1 E of 2 is nothing but language of E into language of E of 2. Okay, then we have regular expression definition, that is part 3. If regular expression if E is a regular expression, then E star is regular expression too. That is nothing but L into E star. E star is nothing but the number of times E repeats in the language. Therefore we can write them as whole bracket L of E whole star. Closure. So closure or clean closure is nothing but the set of strings w1 or w2 for some n is greater than or equal to 0, where each w of I is L of E. Precedence of operators. Parentheses may be used wherever needed to influence the group of operators. Order of precedence is a star highest, where then concatenation, then plus lowest. Plus is the lowest while star is the highest, then concatenation comes in the between. Examples of regular expression: L of 0 1 is nothing but 0 1. L of 0 1 plus 0 is nothing but one string is 0 1 and another one is 0. It consists of language of 0 and 1. Then L of 0 whole bracket 1 plus 0, that is 0 1 plus 1 0. These are all the examples of regular expression and how it can be implemented. All strings of zeros and ones without two consecutives are known for this regular expressions. Equivalence of a regular expression and automata. We need to show that if for every regular expression there is an automation that accepts the same language. Pick the most powerful automation type, that is epsilon NFA, and we need to show that for every automation there is a regular expression defining its language. For consider DFA, converting a regular expression to epsilon NFA proof is an induction of the number operators in the regular expression. We always construct an automation of the special form. Then we have forming of the epsilon NFA constructed. Start state, we have the final state and the intermediate state. The only start state is for the external preceders, and the final state for only except a state that with external preceders. No arcs from outside are leaving the intermediate state. Regular expression to epsilon NFA, basic thing is node starting node to an ending node, while language A is given. Epsilon when every how many ever languages or regular expressions are given inside the language. Phi when there is no value or a string present in the language. Regular expression to epsilon NFA, we need to from one node to another node, we use epsilon for E1 and other node to epsilon to E2. Then we can concatenate these two by using the union for both the E1 and E2. Then we have something for concatenation, that is joining of for E1 E2, that is for E1 epsilon E for E2. RE to epsilon NFA, induction 3 closure. For example, epsilon at initial node we get the epsilon. For the second node it constantly repeats to the epsilon within the intermediate loop for the regular expression. DFA to regular expression, a strange sort of induction state of the DFA are assumed to be 1, 2 and n. We construct RE for the labels of the restricted data in the path. Then we have the k path. A k path is through the graph. The DFA goes through the no state number with the highest number of k value. And for example, 2 power k is the number of times it iterates through the same node. Then we have an example for the k-path algorithm. We can see in this diagram for 0 path 2 to 3 it is 0. Then we have one path for from 1 to 2. 1 to 3 is 1 to 3 is 0 plus 1 1. There are two paths. So like this we can see the different paths, and maximum number of efficiency can be found out using this. So like I discussed, 2 power k, let r power k be the regular expression for the set of labels of k path. Basic is k is equals to 0, then sum of labels of the arc from will be I to j. Phi is no such argument is present. So let's add I is equals to j. Okay, then we have a inductive case example, a k path example where I to j in either never goes back through the k state or goes through the k state with more than one time. We have this formula in which we can apply the regular expression formula to find the current state values. Similarly, we can implement the final step and find the best k path values. Algebraic laws for regular expression, union, concatenation, behavior, sort of like addition and multiplication. Plus is a commutative and associative. Then concatenation, distribution over the plus. Exception, concatenation is not commutative. Identities and we have all these identities, that is 5 that identifies for plus, then we have epsilon that identifies for our regular expression, then we have 5 that is an annihilator for concatenation. Summary: each of the three types of automata we discussed are regular expression as well as define exactly the same set of languages, the regular languages. I hope you understood the video. Thank you.